All right, this is part 2 of our Box-and-Whisker plots lesson. Let's do this next question. The Box-and-Whisker plot represents the lengths in seconds of songs played by a rock band at a concert. Awesome. Yeah, dude, all rock. Okay, so it says find and interpret the range of the data. Well, let's see what we got here. Song length in seconds. Okay, so 140, 160. So some of these are getting pretty long, 320 all the way at the top. Okay, it looks like the least value was 160. The greatest was 300. The median, right in the middle, that's 260. And then we have the first quartile at 220 and the third quartile at 280. The range, see, it's interesting. In a Box-and-Whisker plot, the only two values you know for certain in the data set are the greatest and least values. And of course, the range is equal to the greatest value minus the least value. And so we can say that the range in this case is equal to 300 minus 160. And I can daisy chain equal signs here because these are actually all equal. And that's 140 seconds. 2 minutes and 20 seconds. All right, so now the next one says describe. Oh, wait, and by the way, that range is telling you kind of how spread out the data are. The problem with the range, and the reason we'll use the IQR, okay, which we're going to get to in a second, is because the range can be affected by those outliers. We'll get to that. Describe the distribution of the data. Okay, so describe the distribution of the data. Well, it's kind of, you see how most of the data is concentrated between 260 and 300. So if we had kind of a histogram of the data, we don't know this, but it would be something like this. Most of the data are concentrated on the right. And so this is skewed to the left. This is skewed to the left. Right, which means that most of the data are concentrated on the right, and then there's this dribble of data that's going off down to the left. I think in 6th grade we talked about it as a slide. You climb up the ladder, the direction you'd slide down the slide is the direction that you put in next to skewed. So you'd slide down to the left, so this is skewed left. Next question says, find and interpret the interquartile range of the data. Okay, interquartile range. So just like I was saying a second ago, this, or a minute ago, this range can be affected by outliers. So this 160 seconds may be an outlier. It's way down below the rest of the data. And so it can affect the range, and it can make it seem like the data are more spread out than they really are, right? So in that case, we use the IQR, which is going to be the range of the middle 50% of the data. So you take the, well, I'll put it here, IQR is equal to Q3 minus Q1, which in this case would be 280 minus 220. Minus 220, and you get 60 seconds. Okay, now I would write this out. I'm going to verbally interpret this. Interpret means we're going to put labels on these things and actually explain what they mean. So it means 50% of the songs that were played were within 1 minute of length, right? From 220 seconds to 280 seconds. So half the songs were that long. Okay, last question, part D. Are the data more spread out below Q1 or above Q3, and explain? And below Q1's from 220 to 160, how far is that? That's going to be 60 seconds. And above Q3, that's 300 to 280, that's 20 seconds. So certainly below Q1. And then to save you from having to watch me write, which is going to take forever, let's explain. Well, the range of the data from the least value to the first quartile, 60 seconds, and the range of the data from the third quartile to the greatest value is just 20 seconds. And that's how we know that below quartile 1 is longer. Now, we did this second one, describe the distribution of the data set, skewed left. Let's actually formalize how we describe the shapes of distributions on a Box-and-Whisker plot. And that's this next section down here. Okay, so shapes of Box-and-Whisker plots. So once again, you can see 50% of the data is here. It's concentrated in this rather narrow stretch, while 50% of the data is here, which is a kind of, it's a longer stretch, right? And so we know that the concentration of data is on the right, and if the concentration of data is on the right, it would look something like this on a histogram. This is skewed left. In other words, the left whisker is longer than the right whisker, and most of the data are on the right side of the plot. 50% are here. So that's where most of the data are. Let's go to skewed right. The right whisker is a lot longer. You can see that most of the data are here. Whoa, I did that a little pronounced, but you get the point. The right whisker is longer than the left whisker, and most of the data are on the left side of the plot. Most of it's here. Now, if it's pretty much even between on the left side of the median, this side and the right, if they look like a reflection of each other, like I could draw a line of symmetry here and the right side is a reflection of the left, then the whiskers are about the same length and the median is in the middle of the plot. And this just means that you have a symmetric data set. It's what we call a normal distribution, or the bell curve. I can't draw it very well here, but you're gonna have something like this. Oh, I didn't do it very well, but you get it. The bell curve, and that's something that you're gonna study a lot of. And when you get into statistics, so many things that have to do with the bell curve, confidence intervals, etc. You'll get there, trust me, it'll be fun. Oh, and standard deviation is what we usually use on a normal distribution. Okay, but anyways, we're moving on to the next question. We have a double Box-and-Whisker plot, which represents the test scores for your class and your friend's class. I don't know, looking at your class, looking at your friends, I gotta say, you're probably in the better situation here. Okay, identify the shape of each distribution. Okay, this blue one, most of the data are concentrated on the right. That right whisker is shorter than the left one, so this is skewed left. It's skewed left. And this, your friends, looks like it's pretty even, so I think this is symmetric. It looks like there's a line of symmetry here, and the left and the right sides are, the whiskers are the same length, and they look like a reflection of one another. Okay, which test scores are more spread out? Explain. Now, this is where we can do a visual analysis or a mathematical analysis, and I'm going to do both, and I'm going to do them verbally, and that's cool. Well, maybe I can write a little bit, but you can probably go, okay, I'm looking at this, and it looks like your friend's is longer. Since they both have the same greatest score, your friend's goes all the way down to 60, while yours goes down to, I don't know, between 65 and 70, right? So these are more spread out. But what I'm really doing is I'm thinking about the range. I'm doing the range of each data set, and I'm going, oh, yes, the red one's more spread out. It's possible that you have some huge outlier that makes, like, what if, like, you know, one person didn't show up to your class's test and they got a 0 and their dot's way over here. Most of the data are here, but that one outlier is making it seem like the data are more spread out in your class. So it's actually usually better, or at least I see it usually done. If we don't know if they're outliers, it's better to use the IQR to determine which data set's more spread out. Even using the IQR, though, you can see that the range of your friend's class test scores is greater than the range of your class test scores. And you could actually calculate about what that'd be, 95 minus 85. Your IQR is about 10, and your friend's is 90 minus 70. It's about 20. And so you can see, oh yeah, your friend's is definitely more spread out. Now, the summary. How do you plot a Box-and-Whisker plot? Use, I know I'm actually doing the summary because somebody actually complained. Use the 5-number hashtag summary. Oh, I'm getting really lazy. Summary. Oh, and you know what? I'm going to make a box. Whoa, I was the capital B. Hold on. Oh, it takes so long. Box and whisker plot. Look at that. Using symbology. How beautiful. You are all incredible. Good job. Now get your homework done. If you actually watched the video. Bye.